Hey, I'm Matthew Mills. This is our project group, and we're named It's Always Sunny in Starkville. Our group put a lot of time and effort into doing our experiment, coming up, brainstorming for the thing.
Hello, my name is Brandon Garcia. I was the team editor and cameraman, and I took care of most of the scenes in this project. Travis?
Hi, my name's Travis, and I was the main equipment specialist, and I set up most of the experiment and helped perform tests. Okay, for our experiment, we first set up this engineering masterpiece where we took a pair of pliers and we electrical taped them to a syringe. In the syringe, we laced the sides with some vegetable oil in order to make sure that the piston could freely move without too much interference from friction or any other sort of thing like that. And what we did next after that is we took the syringe, we unscrewed the end, which we also sealed.
Sweet.
In order to make sure that there was no airflow in or out during the experiment. We took this in and we placed it in the freezer in this case of ice right here. This way we got the air inside to be as cold as possible in order to make the extremes more relevant so that the experiment would go more smoothly. And then after that we resealed, we resealed the syringe, we taped it to the side of this pot, which has actually lowered water level, but we taped it to the side of the pot and we turned on the stove to where the water would boil. And after a while, the syringe would eventually move up due to the increasing temperature and the
In our experiment, we had a syringe. We initially put it in a freezer, drew in air to about 25 milliliters, as you can see in the picture in the top left-hand corner. That means we initially had a very low temperature. We then plugged the end so that this was a closed system, meaning no mass could transfer into or out of the system. That means between the two states, we had constant mass. We then put the syringe into a pot and added heat to our system so that the temperature finally was very high. This caused the volume to increase to about 26.5 milliliters. In Thermo 1, we talk about the initial and the final states of a process. I'd like to talk just for a second about what happened in between. This was a non-equilibrium process because one of our intensive properties was changing between these two states. Specifically, specific volume. Because our volume initially was smaller than our final volume and our mass was held constant, our specific volume actually increased throughout this whole process. That means this was a non-equilibrium process. Now, because this piston was allowed to move freely, that means ideally the pressure on the inside of the cylinder will always equal the pressure on the outside, which is atmospheric pressure. In reality, that's not really the case because the weight of the piston and friction along the insides of the cylinder walls affects the pressure difference some, but we neglected that. So that means the pressure here will always equal the pressure outside. That means we have an isobaric process. Because this is an isobaric process, the only thing changing when we increase the temperature is our volume. we can use ideal gas law because air is an ideal gas. When we raise the temperature, when keeping the pressure, the mass, and this constant, we increase the volume. That's exactly what happened in our experiment. In the upper left-hand corner, you can see as we increase the system temperature, our piston moved up because the volume increased. We can calculate the work done on the piston by our system by this integral here. The pressure times dV from the initial volume to the final volume is our work. Pressure is constant, we can pull it out the integral, and we know the volume initially and the volume finally, so we can say pressure times V2 minus V1, which is pressure times the change in volume. Why did our system's temperature change from a low temperature to a high temperature? Well, obviously that's because we put our system into a pot where the outside temperature was very high. That means that heat was put into our system. Since heat is just a transfer of energy across the system boundary due to a temperature difference, we can show this mathematically using the first law of thermo. The change in energy within our system equals the heat added minus the work out. The change in energy equals the change in internal energy plus the change in potential energy plus the change in kinetic energy, but we're going to ignore potential and kinetic because they're practically zero. So that means it is just the change in internal energy. I'm going to call this final. Equals the heat in minus the work out. That means the heat in equals W plus the total final internal energy minus the total initial internal energy. We can actually relate the change in internal energy to temperature using specific heat. So we can sub that into our original equation, saying that our heat in equals the work out plus our mass times CV times the final temperature minus the initial temperature. Very cool. Y'all, that Thermo Project, we did really good on it. I feel really good about it. I learned a lot.
Yeah, I think we did so well, we don't even need to study.
Yeah.
What's thermo?